mushroom cloud snakes skyward, hurling the atom's deadly radiation high into the heavens.
So I think when I did the demo with sodium and water, it showed that the hydroxide is produced because the solution turned basic, and the hydrogen was produced because it exploded into flames. But how do we know that there were sodium ions present? How do you know there are ions in any solution or even in a salt? Well, we've got to demonstrate that, I think, is the best thing to do. So what I have here is just some water. I'll put that there, and more water. Then I have this awesome testing machine, which is lethal in the wrong hands. I'll plug this in here. And there is a light bulb on the bottom, as you can see, which will be on the top in a minute. And there's a couple of electrodes sticking out the top. And if something connects the electrodes, the light bulb lights, okay? So obviously a piece of metal conducts electricity very well. The electrons fly through it and the light bulb lights up. Now, how about water? Is that an electrical conductor? Distilled or not? Some people, no, it's not distilled. It's out of the tap. Some people say yes, some people say no. What do you think? Not enough to light up the light bulb. But if I was having a bath in there and somebody threw this in, I'd be dead. Okay? There is enough electrical current passing through there to zap a person, but not enough to light up a 20-watt light bulb or whatever this is. So not a whole lot of current travels through. In a light bulb like this, you might have an ampere of current to light it up nice and bright. In the bathtub, it only takes milliamps to go through your body to kill you. Okay, so distilled water, or just plain tap water, not much conductivity. Now, what is it that carries charge? In the case of this thing, it's electrons being transferred through the spatula, and the electrons are mobile in the metal, so they are what carry charge. But what if we have something in solution, like some sodium chloride, common table salt, safety seal. So let's put some salt in here. Stir it up a little bit. Now, this is dissolving, and my claim is that this is turning into ions, but the only way we could know that there are ions in there would be to show that the solution has some electrical conductivity, and you can see that, of course, it does. So what's happening here? It's the ions now in the solution that are carrying the charge. Positive and negative charges, positive sodium ions, negative chloride ions, those are the things that are carrying the charge from one electrode to the other and completing the circuit. In ordinary water, there are not sufficient number of ions. There are some ions, but not a sufficient number to see that enough current would be carried to light up this thing, light up this bulb. Now, does it mean that when we dissolve something, it necessarily conducts electricity? Well, here's some sugar. So I'll throw some sugar in. Stir that around. You know that sugar is fairly soluble in water. I put about the same amount of sugar in there that I had sodium chloride in the other one. So let's see what happens. Zippo. So just because something dissolves in water does not mean that it has separated into ions. The sodium chloride does, the sugar doesn't, but yet it's still soluble. So there's two different things going on in there. This, by the way, tells you how you can really kill someone. You throw sodium chloride in the water first and then throw the toaster in the bathtub. One of my favorite shows is called Mythbusters. I laugh my head off when they do things. And they demonstrated this, and they threw sodium chloride in and threw their dummy in, and yes, he got electrocuted more than if there was no sodium chloride in. Somebody have a question?
Your body has salt on it too, right?
Your body has salt on it, that's true, just not enough. If you put more in, you get more conductivity, and the guy is even deader.